In 1972, scientists discovered uranium rocks in Africa that had undergone nuclear reactions 2 billion years ago, naturally, without any technology. This discovery proved that nuclear signatures can survive in Earth's geology for billions of years, making scientists wonder what other technological traces might be hiding in plain sight. Deep ocean sonar has revealed geometric patterns on the seafloor too regular to be natural, while ice cores contain atmospheric chemicals that don't match any known biological or geological process. These anomalies appear in rock layers from multiple time periods, always coinciding with sudden leaps in evolution that happen too fast for natural selection alone. But if an advanced alien civilization lived on Earth millions of years ago and then vanished, would we even be able to recognize the evidence they left behind? Scientists know that all technology leaves marks on a planet. When we burn coal, we change the air. When we make plastic, tiny pieces spread everywhere. These marks are called technosignatures. But here's the puzzle. Time destroys almost everything. Wood rots in decades, metal rusts in centuries. Even our biggest buildings will crumble in thousands of years. The Empire State Building would be gone in 10,000 years. Our concrete highways would crack and disappear. Nature takes back everything we build. What if aliens lived here millions of years ago? Would we find any proof today? Deep underground, strange metal pieces sit in rocks that formed long before humans existed. These metals don't match anything on Earth. They're arranged in patterns too perfect to be natural. Scientists found them by accident while drilling for oil. The metal pieces are harder than diamond and don't rust like normal metal. They contain elements that shouldn't exist in nature. Some pieces show tiny markings that look like writing, but in no language we know. The rocks around them are 65 million years old. That's when dinosaurs died out. Something made these metal objects and left them behind. But what kind of being could create technology that lasts longer than entire species? Earth is 4.5 billion years old. Human cities are only a few thousand years old. Imagine Earth's history as a thick book with 4 million pages. All of human civilization would fit on just one page at the very end. Scientists wanted to know what would happen if humans disappeared tomorrow. They studied how fast our world breaks down, rain wears away stone, wind blows away metal dust, plants grow through concrete cracks, rivers wash everything to the sea. In just 100 years, most wooden buildings would rot away completely. Steel bridges would rust and fall down in 300 years. Our biggest dams would crumble in 1,000 years. Even Mount Rushmore would lose its faces in 50,000 years. After 1 million years, almost nothing human would remain. Maybe some plastic bottles deep underwater, some radioactive waste buried in mountains, a few gold rings in the right spots. That's it. Now think bigger. What if aliens built cities here 65 million years ago? That's 650 times longer than our example. The chances of finding anything they built would be almost zero. Only the toughest materials could survive that long. Things made from rare metals that don't rust. Objects buried in perfect conditions where nothing changes for millions of years. We might walk over alien ruins every day and never know it. In 1972, French scientists were studying uranium rocks from a mine in Gabon, Africa. They expected to find normal uranium, but something was wrong. The uranium showed clear signs of nuclear reactions that had happened naturally 2 billion years ago. These ancient nuclear reactors ran by themselves for hundreds of thousands of years. No humans built them. No aliens either. Just the right mix of water and uranium created nuclear power long before any life existed on land. The discovery shocked scientists around the world. It proved that nuclear reactions leave traces that last billions of years. The uranium had different isotope patterns that could only come from sustained nuclear chain reactions. These signatures were so clear that scientists could tell exactly how the ancient reactors worked. They operated in cycles, turning on and off as water levels changed over thousands of years. But here's what made scientists think differently about the past. If natural nuclear reactions could leave permanent marks in rocks, what about artificial nuclear reactions? What about other high-energy industrial processes? Scientists began looking at rocks with new eyes. They started finding unusual isotope patterns in layers from different time periods. Some showed carbon signatures that looked like massive fossil fuel burning. Others contained rare metal concentrations that seemed too organized to be natural. These weren't proof of aliens, but they were puzzles that didn't fit the story scientists thought they knew about Earth's past. 65 million years ago, a massive asteroid slammed into Earth near what is now Mexico. The impact was so powerful, it threw rock and dust high into the atmosphere. This debris spread around the entire planet and settled into a thin layer in rock formations everywhere. Scientists call this the iridium layer because it contains high levels of iridium, a rare metal that comes from asteroids but is almost never found in Earth's crust. The layer is only as thick as a coin, but it appears in rocks on every continent. It marks the exact moment when dinosaurs went extinct. This discovery taught scientists something important. Single events can leave permanent traces that last millions of years. If one day of asteroid impact could create a worldwide signature, what other events might have left similar marks? Scientists began looking for other unusual layers in Earth's rock record. They found several thin bands containing strange metal concentrations that don't match normal geological processes. Some layers show platinum and rhodium in patterns that look like they came from high-temperature industrial activity. Others contain carbon isotopes that suggest massive burning of organic materials all at once. These mystery layers appear at different times throughout Earth's history, often during periods when many species suddenly changed or went extinct. Each layer tells the story of a single moment when something dramatic happened to our planet. But what created these signatures remains unknown. Scientists now look for technosignatures the same way they search for alien life in space. They study ice cores for strange chemicals that don't belong in Earth's atmosphere. They examine rocks for unusual isotopes that only come from high-energy processes. They map ocean floors using sonar to find geometric patterns that nature couldn't create. The idea is simple but powerful. Any technology advanced enough to cross space between stars would leave traces we could find even after millions of years. These alien visitors would need enormous amounts of energy to power their ships and cities. They would mine metals and change the chemistry of air and water. They would build structures and create waste that doesn't break down easily. All of these activities create signatures that get preserved in Earth's geological record. Scientists use mass spectrometers to measure tiny amounts of unusual elements in ancient rocks. They send robot submarines to scan the deepest parts of the ocean, where crushing pressure preserves things perfectly. They drill through miles of ice in Antarctica to read the history written in frozen air bubbles. Each technique searches for different types of evidence, but they all look for the same thing: patterns that are too organized, too precise, or too unusual to happen naturally. The search requires patience because the evidence would be scattered and faint. Like trying to solve a puzzle where most pieces have been lost to time. Earth's deepest ocean trenches are like giant time capsules. 7 miles down, the crushing pressure is 1,000 times stronger than at the surface. The water is ice cold and completely dark. Nothing rots here because there's no oxygen. These conditions preserve things for millions of years better than anywhere else on our planet. Scientists use sonar to map the ocean floor by sending sound waves down through the dark water. The sound bounces back and creates pictures of what lies below. In the deepest parts, they found things that don't look natural: long straight lines that run for hundreds of miles across the seafloor, perfect circles and squares that are too regular to be made by underwater currents or earthquakes. Some areas show raised patterns that look like the foundations of massive structures now buried under thick layers of mud and sand. The shapes are geometric and organized in ways that ocean processes can't explain. Deep-sea cameras lowered on cables have photographed strange mounds on the abyssal plains. These underwater hills are arranged in neat rows like city blocks. Each mound is exactly the same size and spacing. Ocean currents flow in random patterns, but these formations show clear planning and design. Whatever created them had to work against the natural forces that shape the seafloor. The deep ocean holds Earth's oldest secrets in its cold, dark embrace. DNA carries records of Earth's history written in a code made of 4 simple letters. Scientists can read this genetic story to learn how life changed over millions of years. Usually, evolution works slowly. New traits develop gradually as creatures adapt to their environment over thousands of generations, but sometimes scientists find genetic changes that happened much faster than normal evolution allows. These rapid jumps appear in the fossil record like sudden leaps forward in complexity. 540 million years ago, something called the Cambrian explosion occurred. In just a few million years, simple ocean creatures suddenly developed eyes, shells, claws, and complex body parts. This should have taken much longer according to normal evolutionary rules. The genetic changes needed for these new features were enormous and happened almost at the same time in many different species. Scientists have found similar rapid changes at other points in Earth's history. New genetic abilities appearing suddenly in multiple species during the same time periods. These evolutionary leaps often match up with the same rock layers that contain unusual metal signatures and isotope patterns. The timing is too perfect to be coincidence. Something was causing dramatic changes in Earth's life forms at specific moments in history. Natural evolution could explain some of these events through environmental pressures and genetic mutations. But the speed and coordination of the changes raises questions about whether other forces might have been involved in shaping the development of life on our planet. Earth has stayed just right for life for billions of years, not too hot, not too cold. Scientists call this the Goldilocks zone, like the fairy tale where everything was just perfect. But keeping a planet comfortable for life is much harder than it sounds. Our sun gets brighter over time. Massive volcanoes should have poisoned the air. Asteroid impacts should have frozen the planet under clouds of dust. Ice ages should have turned Earth into a giant snowball that never thawed. Yet somehow, through all these dangers, Earth stayed warm enough for liquid water but cool enough to prevent the oceans from boiling away. The planet's temperature has wiggled up and down, but it always bounced back to life-friendly conditions. This stability puzzles scientists because other planets in our solar system couldn't maintain it. Mars lost its atmosphere and froze. Venus got too hot and became a burning wasteland. Earth threading the needle between these extremes for 4 billion years seems almost impossible without help. Some scientists wonder if this perfect balance happened by accident or if something was managing Earth's climate on purpose. Natural processes can explain some of the stability through chemical cycles and geological feedback systems, but the precision and timing of Earth's climate corrections look suspiciously like active management. If ancient visitors wanted to keep Earth suitable for life, climate control would be their most important job. A planet-sized thermostat operated by invisible hands across deep time. Today's technology can find traces our ancestors missed completely. Quantum sensors detect magnetic fields so weak they measure just billionths of Earth's normal magnetism. These sensors can spot tiny metal objects buried miles underground by reading the faint magnetic shadows they cast. Chemical analysis machines can find individual atoms that don't belong in rock samples. Scientists feed ancient stones into mass spectrometers that separate elements by weight with perfect precision. If just one atom out of a trillion is different from what should be there naturally, these machines will find it. Satellite mapping reveals hidden structures beneath forests, deserts, and ice sheets. Special cameras see light wavelengths that human eyes cannot detect. They spot geometric patterns on the ground that look random from up close but show clear organization from space. Ground-penetrating radar sends radio waves deep into the Earth and listens for echoes that bounce back from buried objects. The radar can see through solid rock and map underground chambers that have been sealed for millions of years. As our tools get better, we keep finding more things that don't fit the natural history we thought we understood. Strange isotope patterns in ice cores from Antarctica. Unusual mineral formations in deep ocean trenches. Geometric anomalies detected by satellite surveys. Each new discovery adds another piece to a puzzle we're only beginning to solve. The evidence doesn't prove aliens lived here, but it shows how much we still don't know about our planet's mysterious past. The Technosignature degradation hypothesis doesn't prove aliens lived on Earth, but it shows that we might never know for sure. Advanced civilizations could exist and vanish, leaving only faint traces that look natural after millions of years have passed. This idea changes how we think about life in the universe in important ways. Intelligence might be much more common than we thought. If technological species can develop and disappear repeatedly on the same planet, then countless civilizations might have risen and fallen throughout cosmic history. We might not be the first technological species to call Earth home. The strange patterns in rocks, the rapid evolutionary changes, and the planet's unusual stability could all have natural explanations that we simply don't understand yet. But they could also be the fading echoes of visitors who came and went long before humans existed. This possibility makes our search for life in space more hopeful and more urgent. If aliens visited Earth before, they might visit again. If intelligence emerges naturally and repeatedly, then the universe could be filled with technological civilizations we just haven't detected yet. Our own civilization is still very young. Humans have only been using advanced technology for a few hundred years. If we're not careful about how we treat our planet and each other, we might become just another mysterious layer in Earth's rock record. Future species might find traces of our plastic and wonder what kind of beings created it before vanishing into deep time.